So this is my solar cooker designed for 2025, and this guy is he's scaled for he's supposed to be about 6 feet tall, so 180 tall roughly. This represents a 5-gallon container, and this represents a parabolic dish. I can't actually make a parabolic dish that tiny, and a parabolic dish has a offset focus which is here, and this little thing denotes how a light ray, if you can imagine it straight, would reflect to that point. This here is it's a sun pointer, so it moves. It's on something called equatorial mount. This faces exactly due north, and this is at my latitude, so the angle here is 48 degrees, which is my latitude. And so as this follows the sun, the rays of the sun concentrate just under the cook pot all day. So it's currently set for equinox, so it follows the sun until end of the day, and then it comes back to the start point for the next day, and then at the appropriate time it starts following the sun again. So it's a tracking solar cooker, and I'm just going to show you the change for, so this is set for equinox, which is 21st of March roughly, and 21st of September, 21st or 2nd of September. I'm going to put to winter, so the winter setup for it is here. So this is the midwinter setup with the sun lower in the sky. You can't see the pointer, but with the sun lower in the sky, the sunlight is going to come from here in, lower down, and it's going to reflect up to the same spot. So as you can see, it starts up around here, follows the sun, and it keeps following the sun around until the end of the day, which is probably something around here. I can't remember exactly, because the daylight isn't as long in winter. So now that's winter solstice, and we're going to go up to summer solstice, which is 22nd of June, and so this is how it's set for the summer solstice, when the sun is high in the sky. So in the morning, some of the sun comes from north of the east-west line. So sun starts about there, and turning around, the light is still pointed, concentrated under the cook pot until the end of the day, and then at the end of the day we reset back to the morning time, which is about here, and ready to go again. And the issue with the standard parabolic dishes is they can't just track in one axis. This tracks just by rotation, and you would manually change the declination angle, which is based on the time of year. So we can have marks here, angle marks, donating the month and the date, or donating the date. So you can have the dates all along here and just change it. You don't have to do anything fancy. Just change it every other day, and it'll be fine, because this is a design for home use. The reason for this here, this is a chenille. I'm just going to check Where are we at? So because the light will be shining up here, this works as a shield, and this here is a hole to let in, so it could be covered with glass or thermally resistant plastic, but this is where the light and the heat will heat the cooking pot underneath, and then all this cooking pot can be well insulated. There could even be a little full-scale oven in here where you would get and put things in and out from the back, where there's no issue with getting blinded, because that's an issue with parabolics, is the light is potentially dangerous. But if we have this area here shielded off with something probably a bit bigger in real life than what I've shown here, it will protect everyone's eyes, and as long as it follows the sun, eyes are protected as well. So anyway, that's the plan for the solar cooker for the next while, and I'll just I'll just stop it there.